Hey guys, this is Manak, your Silvero, and welcome to this video. And today we're going to see how to do some shear force and bending moment diagrams in STAAD, and we'll see the results as well. So if you look around some standard shear force and bending moment problems, we'll try to solve them in STAAD.Pro. So let's begin. So first of all, we'll just create a new file and maybe just change the name of this. Okay, and then create. Okay, so now let's look at the very first problem which we have here. This is we have here a simply supported beam, and we have some loads which are present here. So these are in meters, these coordinates. So if you I'll add the total load, total length, sorry, 1.5 plus 2.5 this coordinates. So the first coordinate is 0, just tab 0 and out. And the next coordinate, if we're doing in the x direction, this is 1.5, 1.5, 0 and 0. And the next coordinate will be 1.5 plus 2.5, which will be equal to 4. And then we have 4 and tab, and we go to the next one. And then we have plus 2, that will be 6, 6, and then we have plus 2 again, that will be 8, and that. So these are the coordinates, and we'll go to geometry, click here, and then add beam, and then add the points, single click. So the nodes are connected. Now we need to click on escape, and we'll assign the supports. So for assigning supports, we will select node cursor and select this cursor, and the node tools appear. Then we'll go assign supports and then create. And we have the option of fixed, pinned, and this all these things. So this is simply supported. So I'll just go with this pinned, and here in this option we have all the forces restrained in the simply supported condition. So we'll just add this support to, and this support to, and just select this and control and select this and assign here. So these supports are assigned, and once the supports are assigned, we will just give on the loads. So first of all, since this is a actual beam, so we're going to go to assign the properties, and here in this particular, all the problems which you solve in exam, you won't find any your sizes of the beam, because they take the center line of the beam or the neutral axis of the beam, and then we do it. But here this is an actual beam. So we're going to give the properties. So you just click on define and rectangle, and we're going to go with the size of 250 into 350. Click on add. And when you go assign to view, assign this. So the beam properties have been assigned. Now we go for the loading. Load case details, click on add, and let's go for the dead load first and call it DL. Add, and then click on the line dead load. Self weight in y direction, self weight will be added. And then we have modal load, and modal loads will be in the direction of Fy, that is coming from the top to bottom. And let's see the nodal loads in 40, sorry, is 4, 10, and 7. So it will be -4, add -10, minus because it is acting from top to bottom, and -7. So select this, and just go to the node cursor, and you can see the nodes here. So select this and select the first node, and assign to selected nodes, assign, and yes. Select this, select the second node, assign to selected nodes, assign, and yes. And then click on the third one, select the third node, and assign to selected nodes, assign, and yes. So, and then self weight you need to assign to view. So self weight has been assigned and all the loads have also been assigned. So now simply, there are many ways, but easily we can do, we can just go to analysis and design, select concrete, select the code in which you're designing. In this case, I'll select the Indian code, select the parameters. We don't need much parameters, just give the, we need to give the FY main and FY secondary, and we need to also give the FCK or the strength of concrete, and that should do. Okay, and click on OK, and three parameters are there. FC will be M25 25,000 at FI main. FI 550 bars are even used now, 550, and then 1 2 3, and add for secondary is 550 1 2 3. Click on add and then close. And then we'll also take the command of design beam and close. So FI this will assign to view. All the things will be assigned to view here. So and then we'll go to analysis commands, no print and add. And then we'll run analysis. So if you have any error, then it will take some time. If you have any error, it will show immediately. If you don't have error, it will take some time to just complete the process. Looks like that. So it didn't show any error. So building beam has been designed. You can double click and see the concrete design as well. Given 2 bars of 10 at the top and 3 bars of 10 at the bottom. So this is the design, but now we're going to look at the shear force and bending moment diagram. For that, you can just go to the post-processing mode, and you can easily select the result view options and loads, which is available. Now we are only the dead load. So the dead load is available, and range and all. Just click on apply and OK. Okay. So first and foremost thing which you will find is the displacement has been by default selected. If you want to increase it, just just press Control and then plus, and you can see the deflection of this simply supported beam. And hold Control and just zoom in button of your mouse wheel, and it will show that. Now we'll turn off the displacement and we'll see the F1, and which is the shear force diagram. So you have the shear force diagram here. I can see that. Now let's turn off the shear force diagram and we'll see the moment in the bending moment diagram. That is the MZ. So we'll see the bending moment and the shear force diagram. So if you need these values, you can find the values of these things here. And also, if you want the values, in the figure, just click on this annotate option, and beam results and bending for ends, maximum and at midpoint, shear at, let's go for the maximum one only, axial at ends, displacement, maximum result, and combined bending. You don't want this. Okay, just click on annotate. Okay. So here you find the values in KIP inch. So these are the bending moment and shear force values. So if I turn off this value and just go for the shear force, you find this maximum shear force in kilonewton. And similarly for the displacement also, you find displacement here is given in inches. You can see this displacement, shear force values, and the moment values. So if you just click on annotate, this will show, and if you just remove all, then the values will disappear. So like this, we can see the results. So now let's aim for a different beam, different kind of beam. Let's see whether we have a different kind of diagram. So you can see you can match the shear force and bending moment diagram from here. And let's see a different type of beam. So this is also a simply supported beam, and UDL is applied in two sections here. And we have let's do this problem because here we have UDL. Okay, so let's do this. So it's better if I just click on a new structure in STAAD, so that we can avoid any type of errors. So here we'll just give here, let's say 2, 2, and 2. This is it. So it's 2. And press tab to go to the next one. Then it's 4. Press tab to go to the next one. Then it's 6. And then here and click here. And then we will just so we'll just go to add beam and add these nodes, and then we'll go to your supports, and then create the pinned support. In this case also add and then close this. So and then we'll add the pinned supports in the two ends, this one, and press control and then press this one, and then assign to selected nodes, assign, and yes, so fixed support has been selected. And then we'll go to the same process. We'll go for the properties and we'll define the properties here. Rectangle, we'll go for 250 into 350, and click on add and close. And then we'll go for the loading, and this is the same process. Click on add and dead load, and this would be DL, add and close. And then in the dead load, just click on add, and then we have added the self weight, and then we have added the nodal load. And in the FY direction, let's see what is the load which has been given. This is okay, not nodal load, this is the UDL. So 10 kilonewton per meter and 5 kilonewton per meter, two portions of UDL, which is there. So in the kilonewton per meter, so will be minus 10. Okay, add, and it is another one is minus 5, I think. Yeah, it's minus 5. The minus for the it is acting in from top to bottom. Add and close. And then self weight, we'll just click on assign to view, assign, and yes. And the minus 10 load. For the minus 10 load, just click on this load and click on this member, and then assign to selected beams, assigned, and yes. And minus 5 load, select this beam, this portion, and okay, I think I have done something wrong here. It's 2, 2, 4, and 6. There are only two parts. Okay, so let me go to geometry and see. Okay, this should be 0, right? That's what is wrong. So 0, then it should be 2, then it should be 4, and then it should be 6. So I've done this wrong here. Okay, no problem. Let's add the beam here, and properties. Let's assign to just control A, control and select this, and assign to select beams, assign, and yes. And then go to the loading, and then go to the dead load here. Now this 10 kilonewton, I will just 10 kilonewton. Let's edit this member and change. Now this is also undefined. This is already defined. We'll just assign to view this again to just add the new member. And now we go to the 10 kilonewton. So 10 kilonewton is here, and we'll assign to selected beams, assigned, and yes. Now for just click outside, 5 kilonewton selected, this one selected, assign to selected beams, assign, and yes. And so this is done. and supports are given. Okay, this support is given in the wrong direction. So I'll just select this support and edit. Okay, I cannot edit this, so I'll just delete this support and create a new one, paint and add, and then we'll select the support, select this, use cursor to assign, select node cursor, select this node, and assign, and yes. So supports have been assigned and corrected, and then we go to design, select concrete, select your code, select the parameters that you need. We need obviously FC and FY, and click on OK. And commands, just design beam, add and close, and define parameters. C is 25,000, that is M25, and FY main is FE550, 1, 2, 3, add FY secondary 550, 1, 2, 3, add and close. Design view, assign to view, assign and yes. This one, assign to view, assign and yes. This one, assign to view, assign and yes. So all will do assign to view here, and then we'll just go to analysis commands, add, close, and then run analysis, save. Structure will save, run the analysis, and then you go. You can just click on this go to first person, go directly to go. Otherwise, you can do like I did previously by pressing this one. Obviously, just click on apply and OK, and press Control. Press Control and plus to see the deflection of this beam, and similarly, just let's see the bending. Shear force diagram. Shift and plus. Control and plus to see the bending moment. Shear force diagram and the moment here. Find this to the bending moment diagram. And if you want to annotate, obviously it's on for the annotate for the bending moment diagram. Beam results, that's bending maximum. Let's see, annotate, and you see the bending moment results. So like this you can do. Now let's do a UVL in this particular beam. Okay, so we'll go to this geometry, and we'll go to loading, and this particular load, in this particular dead load, this 5 kilonewton is here, and we'll delete this, and in this place we'll add a UVL, uniformly varying load. So we'll add here, and this will be in the case of your member load, and in member load we have linear varying, and UVL has 2 values. So let's this value start from -2 to -8 kilonewton per meter, and click on that. Then close it, and then this particular UVL, uniformly varying load, assign to this, assign and yes. So we have UDL in this beam and a UVL in this beam. So we'll just go and run analysis, and we'll see the results. So post processing, and this is the displacement, and this is the shear force. You can see the UVL, shear force, and this is the bending moment. Okay. So MX and MY bending moment are negligible. You know that for the bending moment we have in the MZ direction, and for the shear force, maximum shear force is in the Y direction. So you know this thing. So now in this very thing, if you want to assign, just change the type of supports. Let's say if you want to go for fixed supports, you can also do that. So let's go to analytical modeling, and we'll go supports, and then here let's delete the supports here, and then create some fixed support and assign this fixed support at this end, assign and yes, and let us assign at this one end as well, assign and yes, and then we'll just do the analysis done, post processing, reflection, bending moment, and shear force. This is the bending moment. You can see since it's fixed, you can see the bending moment diagram changes like this. So you can see easily you can calculate the bending moment shear force diagram using this case. So now let's go for an overhanging beam. Or just two fixed and overhanging beam, and one fixed and one pin overhanging, and then one cantilever also. So let's do this. So all the different types of results, possibilities which you overcome and which you come across in real life scenarios, we'll just see this. So we'll go to analytical modeling, and now in place of supports, we'll just let this fixed support be, and we'll just delete this. So we'll create a support here, fixed one, and we'll create another support which is pinned. And we'll assign the fixed support in this node. And we'll assign the pin support in this node. So this is an overhanging beam with fixed and pinned, and then the remaining portion is overhanging. So now let's see the analysis results. Analysis, save, then done, and then just see, go to the post processing mode and see the results here. You can see the displacement, shear force, and the bending moment. You can see this is the things from the annotate. In annotate, let's annotate the shear force, because these are the units which can understand. Shear maximum, okay. And if you do midpoint, if you do everything, it will show you. Okay. Just annotate. So these are the results of the shear force diagram. So now let's go for a full cantilever beam. If you have one and only fixed, and you have the full cantilever beam, let's go for that. So we'll go to analytical modeling, and 2 to 4 and 6 meter cantilever is a large option. So first of all, I'll just go to the supports and delete this supports here. And I'll also go to select and beam cursor, and then delete this, and also go to loading and delete this load which is not assigned. Okay, so we have now a 4 meter span beam here, or let's go for 2 meter only. Let's just delete this as well. We have a 2 meter span beam. So 2 meter beam which is there, and if you just roughly, it will be around 6.56 feet, which is a practical cantilever which you see in many cases up to 4 to 5 feet. You see, so 6 feet cantilever is there, or 2 meter. And let's see the analysis results of this. Done, and we go to post processing and displacement, and then we'll have the shear force. Let's see the values. Same values, shear force, and then we have the moment. So we have the bending moment, shear force, and if you want to annotate and see the bending moment results, maximum, let's see. You see the maximum bending moment results as well. So like this you can do. And another case which you find is in the case of frames. You can also analyze frames also. So for analyzing frames, can just put analytic modeling and control plus A and delete this. Remember sometimes STAAD.Pro, if you just do this, it can result in error. So any error comes, we will just redo this. Okay. So we'll go to geometry, and then first node is 0, 0, 0, and the second node x will be 0. Y will be, let's say, let's take a practical frame, 3 meters, and Z will be 0. Okay. So this is the first node of the frame, and then we have X will be, let's take a 4-meter frame. Okay. 4 and 0, 0, and 4, and we have 3, and then we have 0. So like this, we have drawn a simple frame. So just click here, add beam, and just take this and make the total frame. So this is the frame, and quickly we'll just assign the properties. The rectangle property is already there, so we'll assign to view, assigned, and yes. Properties assigned. Now go to supports, and we create a fixed support. And for the fixed support, just select the two nodes using control. And okay, again, we select this first, and then we select the nodes, and then assign, and yes. Fixed supports have been selected, and all the remaining steps have been done, I guess. Analysis, and so you can see, this error comes mostly because we have, just redone this file. So we'll just do this again. Same thing, same steps, but we'll just create a new file. I already told you this happens sometimes, so just create. Okay, so this time just create the nodes here, 0, 0, 0, and 0, and this will be a 3-meter, 0, and this will be 4, 0, 0, and 4, 3, 0, right? These were the nodes again. So just click on add beam and select this, and so this total frame, and then go to properties, and then just define, and then go to rectangle, and then we'll go for the simple 0.25 and 0.35. Let's go add, close, and assign to view, assigned, and yes. Go to supports, create the fixed supports, select the fixed support, and select the node, first node, control, and select the second node, assign, and yes. Go to design, select concrete, select your code, building code, and then select the parameters which you want. Minimum parameters will take. This is FC, and FY will take this. Okay, and commands will just select design beam, and then define the parameters FC and 25, 3 zeros after 25, and FP 550, 3 zeros after 550. This one is also 550, 1, 2, 3. Click on add, click on close. This all these things will be assigned to view. Yeah, this is done, and after this is done, just go and run analysis, save. Okay, okay. So we have not added the analysis of protocol. Analysis commands, add the analysis, close, and then we do just close this, and then we do run analysis. Okay, we have one error. Let's see what the error is. STAAD.Pro warning. Okay, let's see. Okay, so let's add the loads here. Loading and its details. Add, and first of all, let's add the dead load, and it will be the DL. Click on add, close, and then let's add the dead load. Let's add the self weight first. Only the self weight. Add, and then close, and then add the self weight. Assign review, assign it yes, and then we can check whether everything is okay. 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 So So let's add more loads here. So let's add here UDL. So let's add UDL -5, and we'll add on the top of the frame, add and close. Select this and click on sign to selected beams, sign, and yes, this load has been selected. Press Ctrl plus S, and then use code analysis and design and run analysis. So let's figure out what this error is about. Done. Okay, select text. Okay, let's see. 5,000, 550,000, and complete design analysis finish. Uh, so the problem was I had added load after the analysis, so I deleted the performance analysis, and then again I added the performance analysis. Then it showing. So I forgot to add the load. That's why this error came. But that should not be in your case. So let's see the results which are coming in here. After this, let's go to the post processing mode. Apply OK, and displacement. And since I applied UDL only at the top, you see the displacement like this. And let's see the shear force diagram here. And then we see the bending moment diagram, which is here like this. And now let's play around, and now let's apply some more loads. Then we'll see. Mm, so let's go to analytical modeling, and then go to loading here. And in this load case details, let's apply some more dead loads, add, and we will, what we'll do, we'll add a member load, or let's add a member load or UDL here. In this, let's add. So now if you want to apply a load on this particular part of the frame, that is the right one, right side. So this will be along the x direction. Okay, this will be along the x direction. So it will be along global x. Now global x, if it acts like this, it is positive, and if it acts from right of the stream to left of the stream, it is negative. So I'll just go with negative. Let's say 3. Okay, just to show you, and click on add, and then yes, then click on close. So this I need to select this and assign to select beams, assigned, and yes. So this load is acting like this. So, and again, I'll add a point load here in the center. Okay, at the center of this node, I'll add a point load. So in this case, I'll go dead load, and let's add a point load here. We'll get a nodal load, and this will be x, but this will be in the positive direction. So nodal load, it will be fx, and it will be positive direction. That's at -5 kilonewton nodal load, and click on add, close. So for the nodal load, we need to click and add a node here. So Simple way is just click on add beam, and here you want to add a node here and add midpoint, and then okay. Okay, then click on escape. Then click on escape, add the node cursor back. Select this and go to select and node cursor and select the middle node, and then assign to selected node, assign and yes. So it -5, it is acting like this. If you just change the symbol here to +5, will change this direction. So it is correct now. Okay. This is the UDL, and this is the these are the other loads. So once the loads are applied, what we'll do, we'll go to analysis and design once again. Just delete this since you've changed the load. Just delete this command, delete command, yes, and then analysis command and add analysis once again, and then close. And then you just run analysis. So this is done. So all the loadings are defined, and then you go to your post processing mode, apply OK, and you have the displacement here, and then you have the, and you see the shear force diagram has changed. Let's annotate also beam results. Let's go for everything. I can see the beam results, and then moment also. You can see moment diagram has also been changed. So like this, you can have the shear force and bending moment diagram for most of these support conditions. And if you have any doubts, you can just comment below. And if you have watched this video till now, make sure you like, because it really helps me out to reach more people. Keep learning. Bye bye.